Supplemental math videos from Circle Christian School. Studying. Your book and well-taken notes are an excellent source for studying. Look at the end of the chapter reviews. There is a What Did You Learn guide to the chapter. Try a practice problem from each of the review sections. Look at your lesson notes and then try condensing them into one, at the most, 2 pages of important facts. Only you hold the key of success in your hands. Be able to simplify irrational offenders. All right, since this is square root, remember it's going to take 2 for anything to come out. So we're just going to split them down into those little factor trees. When you get down to the prime numbers, make sure you circle them so you don't lose them. And it's going to take 2 for one of them to come out. 2 2s, 2 comes out. 2 3s, a 3 comes out. And because I have an A, B, and C, I'm going to leave some space there and work on those. We had a 2 stay inside. So I work at the numbers and then I'm going to go to the letters. Number to number, letter to letter. A squared, an A comes out. B to the third, a B comes out, 1 stays inside. C to the 7th, 7 divided by 2 goes evenly 3 times, so we have C to the third with 1 left over. So we have 6ABC to the third power cube root 2BC. Next one is a cube root, so it's going to take 3 for anything to come out. 125 times 5, and 125 we know is 3 5s. Takes 3 for 1 to come out, so the 5's coming outside. The other one's staying inside. And again, because I've got some M's and N's going on, I'm going to give you a little bit of space here. M to the second, hey, there's not 3 of them, so he can't come out. N to the 9th, divided by the 3, evenly, 3 times. And we're good to go. Number to number, letter to letter. Be able to change radicals to exponential expressions. Remember, it's inside power over outside index. The deal here is to change it so that we have same bases and we can use the exponential rules. 2 over 3 times A 1 over the 4. That's going to leave us with A 2/3 plus 1/4. We need a common denominator to be able to add the fractions. And our final result is A 11 over 12. 12 is our common denominator. Same thing happens when we do the division. We just go to exponential rule number 2. It's going to give us a 5 inside power over outside index, so 5 to the 1/2 over the base here of 5 inside power 1 over outside index. And now we can use our power rules of same base, which is the 5, 1/2 minus the 1/3. Common denominator to deal with the fractions. And we get, let's see, 3, 2, 5 over 6. Nope, my bad. So much for mental math. 1 over 6. You also have to be able to add, subtract, multiply radicals. When we add and subtract, you have to remember to have like terms. So sometimes you have to do some simplifying along the way. Going to bring the coefficient of 3 down. Going to simplify the 45 here, which we know is 9 and 5, 3 and 3. 3 is going to come out. He's a factor, so he gets multiplied to the coefficient. And a 5 stays inside. Next one's already simplified. Nice. Hallelujah. And we're going to bring the 8 down. So we have an 8. 125 is 25 and 3. Oops. All right, no big deal. So we have a 5 that comes out, a 3 that stays in. And so now we have a 9 square root 5 minus a 2 square root 5 plus a 40 square root 3. We can only add the like ones together, so that's going to be the ones that have a square root 5. So we have a 7 square root 5 plus a 40 square root 3. Square root 3, square root 5, not the same, so we can't add them together. Multiplying. Number to number, letter to letter, radical to radical. I love the little squigglies. Okay. So, square root 7 times square root 7, which just gives us what's inside. Square root 7 times a negative 4 is a negative 4 square root 7. For some reason the program is being very shaky. So we got a 3 multiplied to everybody here. So a positive 3 square root 7. And then we have a 3 and the negative 4, so it's a negative 12. The middle does afford us to be able to combine them. Doesn't always. So we have a 7 minus a square root 7 minus the 12. I like to put the real number first. Negative 5 minus the square root 7. Okay, be able to conjugate. That's the difference of two squares. Remember, that gives us a real number. We can't have a radical in the denominator. So we're just going to multiply both by the conjugate. So 6 and 6 is 36. Square root of 5 times square root of 5 is 5 minus sign. Nice and neat. 36 take away 5, so 31. And then we have 1 times 6 minus the square root 5. Sometimes you have to distribute that out. It's okay if you do, because sometimes you need to simplify with the denominator here. 31 is a prime number, so I know I don't need to do that, but sometimes you do. Be able to solve radicals. It's all about the inverses. Remember, step 4 of the kingdom step says sometimes you have to isolate the condition. So we're going to square both sides here. What's inside just comes out because it's squared. Any radical times itself is itself. So I'm going to add a 1. I'm going to add 1. 3x equals 226. So x is going to equal, let me think here, 3 into 22 is 7 with 1 left over. 3 into 16, not nice. So we're going to have kind of a fraction thing here. Not a problem. It still works. It goes 5 with 1 left over, so 1/3. Or you can make it a mixed number. Sometimes we have to square both sides. Sometimes it gives us a cute little binomial squared. Depends on what you're working on. But again, a basic example. You can find others in your book to try or ask about. Just send me a message. Gotta get the x by itself. So I'm going to add a 2 here and add a 2 here. Gives us that 4x equals 9x plus the 8 minus a 9x minus a 9x. Negative 5x equals the 8. So we're just going to get rid of that there. Got to throw it back in, make sure it makes a true statement, because if it doesn't, it will be extraneous. So you'll have to tell me whether or not this is extraneous, which it could be. Going to do the last one. Hey, this is a cube root, so that means everything's just going to go to the power of 3. Remember, our odd indexes and powers are okay to have negative results. So a negative 8x plus the 3 equals negative 8 times negative 8 times negative 8 is negative something big. So a negative 512. And we're going to take away a 3 and take away a 3. And we get a negative 8x equals a negative 515. Divide by the negative 8. So x is going to equal a positive. It's going to equal a positive oh my goodness, 515, there we go, over the 8 or the decimal. I'll let your calculators figure that one out. Complex numbers are another thing that you need to do. Remember that I equals the square root of negative 1. That if we have any type of negative radical, for instance, like negative 8, it just means we're going to bypass that negative and call it an I. I squared always equals negative 1. These are the two important ones. Remember, everything works on simplifying these on the 4s or multiples of 4. So you got to look at I to the 4th power, 5th power, 6th power, and 7th power, because those are the ones with the remainders. It'll tell you what it simplifies to. I to the 12th is 12 divided by 4 is even, so it has no remainder, so it equals 1. I to the 26 is that it goes evenly 6 times with the remainder of 2. The remainder of the 2 correlates with I to the 6th power, which is negative 1. Adding and subtracting these is just going to go I to I and real number to real number. Just noticed I had these backwards. It's okay. I like having the real thing up first and the I second, so I kind of like bypass my own theory, but the same game happens. 3i plus 4i is a 7i. See, I'll fix it in the end here. And a positive 6 and a negative 8 is a negative 2. There we go. With subtraction, you just have to watch the sign here and make sure it gets distributed out. So 6i minus a negative 5i would be 6 plus 5, or a positive 11i. And a negative 2 minus, a negative 1 minus the 2 is going to be a negative 3. So we throw it up front. Multiplying, you just have to watch out for the I squares. So 8i times I is I squared here, or 8i squared. Just go ahead and put a negative 1 there. And then we have a negative 16i. Then we're going to do the other guys. 1 times I is a positive 1i. And then 1 times the negative 2 is a negative 2. So I have a negative 8 and a negative 2 is a negative 10. And minus 15i. Then the first guy is going to get squared, which is 4 times 4 is 16 times the negative 1. 1 times 1 is 1. And then the minus sign. So negative 16 and a negative 1 is a negative 17. And the negative 17, I know, looks a little bit different because our other ones turned out positive. That's because when we had a conjugate, perhaps we had a positive, we had a positive number up front with our little conjugates. which would lead us to have a positive number. However, if we truly rewrite the ones that we have here, you'll notice we have 1 plus a 4i, and then a negative 1 plus the 4i. So that's why the difference of this two squares looks just a little bit differently. It's all about the order. Okay. Moving right along. Last one coming up. Conjugate complex numbers. Can't have something unreal down below. So we're just going to do that little conjugate thing, that difference of two square things, top and bottom. So the first one squared, so 9 times the negative 1. Second one squared is a 1. So that's going to give me the negative 1. It's another one that's written just a little bit differently, but that's okay. Negative 9, take away 1 is a negative 10. Going to go ahead and just FOIL things out, so we get a 12i plus 4. Going to rewrite it into reals first, so we end up with a 4 over a negative 10. Throw that at first. And a positive 12i over the negative 10. Going to do a little rewriting, a little bit of simplifying. So this is going to give us a negative 2 over 5 minus sign a, let's see, divide everybody by a 2. So a 6 over 5 and an I. You can graph it. This is the A, this is the B. Remember, this isn't X anymore, this is real. This isn't really Y anymore, this is imaginary. And so I just walk over to the 8 from origin here. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go up 7, 3, 4, 5, 6, 7. And so this is where it sits. To find the distance between the two, we're just going to use the distance formula. I'm going to take the 8 and square it. And I'm going to take the 7 and I'm going to square it, which is going to give me 64 plus 49, which is the square root of 3 and 1, so 113. Nice prime number. And that's how far it is. Or if you do it by calculator, approximately 10 point yada yada yada. And there you go. Radicals and complex numbers. Now go imagine yourself as being something special, that special thing that God gave you. Be with Him.